I'm going to start the session. Really excited to welcome everyone here. So many people here have done great breakthroughs for the purpose of genetic agency and also in particular for AI. I want to do some housekeeping things first and then tell you a little bit about what Dyno has been focused on in this domain and then set us up for the talks. So on the agenda, you might have already seen, we have about 9 talks from different people, although we have one person who couldn't make it, Daniel Burkhardt from NVIDIA. Unfortunately, a flight cancellation yesterday didn't allow him to make it in time, but we still have an amazing roster of people. So it's going to be 9 short talks, and then after that, we're going to have a panel on genetic agency, which Fei Lin gracefully agreed to moderate. With that, also, obviously, depending on the talk that you're hearing, you can also go to the other rooms. Obviously, I believe this is the coolest room to be in. And in order to make sure that's understood by everyone else, I would ask you to give the highest, loudest applause at the end of each talk so everyone else feels the FOMO truly within their bones. And, we know we're the winning room. Aside from that, again, this conference is about having conversations, but in order to have everyone get a sense of what everyone else is working on, we decided to have these breakout sessions. So that's what we're going to do. Just saying a few words about what Dyno has been doing in the past 10 years, really working on this subject. As a team, we're completely focused on making technologies that make genetic agency possible. Within AI, 10 years ago that Eric and I met, and Pierce was also working on this problem, basically, he saw this opportunity to get this match between high-capacity models and high-throughput sequencing to build black box models that can model the function of proteins directly. So as early as 2015-16, we started working on this problem. And for therapeutic subjects and sequences, the functional readout is basically in vivo performance. So Dyno was established around this idea of we want to measure the in vivo function endpoint as the training data, and over time we ramped up our platform to be able to measure many of these sequences at once. And that was basically the sort of trajectory of our black box model that we're still using heavily at Dyno, and you'll see a little bit about the results of it. But 2 breakthroughs in the past 10 years also sort of both surprised us and resulted in us having new leverage that wasn't previously possible. One was the invention of AlphaFold and the possibility of designing against structure directly. So in the past 2-3 years, we've started also using these structure-based models and developing them for our own purposes to do mechanistic-driven design, which is exploits the ideas that we have to be very specific for a particular tissue by knowing the mechanism, something that black box models don't offer immediately by themselves. And then finally, with the advance of large language models and ChatGPT and agents, we are also now developing agents much more recently in the past few months, developing agents that can help you design much more easily. And I'll talk about each of these a little bit before I hand it off to Nima. So with black box design, you probably have already seen this. This is a muscle tissue cut. And each cell that you see that is shining red is a cell that has been transduced by a viral capsid design by Dyno and by Dyno's black box design methods, plus some inventions on top. And that these are basically pipelines that we've set up, and sort of the culmination of them is capsids that work really well. And there's different variations of these pipelines that we have, but one that we also talked about in the past is LEAP, which not only gives you this type of performance, but also gives you this type of performance with very few shots. So as few as like 10 or 15 shots is enough for you to get something that could work as well as this and better than anything in the training data. And we could even try to bring that down slightly more, but what it actually means is that you can skip an entire in vivo experiment, save a year, so you don't need to do the discovery run. You can immediately go to designing something that you're hoping will work. So that's on black box. Dyno Psi-1 is our structure-based generative model that we are very excited about. We haven't announced it yet publicly, but you get a preview of it. The key things we care about is that this model is controllable, and people are really working hard on it right now. I see smiling faces in the audience that the GPUs are going hard today and over the next few months. So hopefully you'll learn more about them soon. But they're very controllable. They can design every component of a gene therapy rather than just the capsid. So we can design payloads now as well. And they can do certain things that we really care about. We can target multiple things at once. We can exploit symmetries and do protein complexes. So some capabilities that are not there yet in other models that are out there, but also really purpose built for our design. And then finally, we have these agents that basically reduces the cognitive load and expertise needed to design a therapeutic. And we're making rapid progress there. You can hear about it from David Levy-Booth later today, both on the panel, but also there's going to be a demo of it in the roundtables later. So please check it out if you're interested. Basically, this thing is that they integrate information, but also the tools that we have at Dyno all together under one roof. And all of these are going to soon be available to you in a box too, which we call Dyno AI Foundry, meaning you can use our state-of-the-art models, you can use our agents to do design, and both of them are improving at rapid pace. But also we can generate bespoke data for you to fine-tune your model or validate something that you've done and integrate it with your own model and data if you want. So these are all the things that Dyno is hoping to offer people. So we're not just a capsid company. We can design your payloads. We can also we can also give you a service to basically have all the technologies that Dyno uses in a box to do your own thing in order to sort of achieve what you want to do in genetic agency. So with that said, we're excited to collaborate with you. If any of this looks good to you, come talk to us during this conference or after. We are open to ideas, to collaboration, and all of those things. This conference is basically trying to bring together people across this entire pipeline, from very computational folks that are building in silico models to people who are in this middle and people who are doing clinical stuff or even point of care with patients. I generally think general intelligence models are making a lot of progress on this side, and more special purpose models are making progress on this side, but these two can come together fairly fast. So just a very crude, like where all the talks today can fall, they fall across this timeline and the pipeline, and obviously many of you would say, oh, I could also be relevant to this other part of it, but I want to say like everyone has like a very wide density of places that their work is relevant.